I am a very active person in the community. Worked at Prolexic, Akamai, Caspita, and been a Splunk back at Splunk for over a year now, and co-founded Hack Miami and Pacific Hackers. Jose, would you like to introduce yourself?
Yeah, I'm also a researcher here at Splunk, security researcher. Also ex Prolexic, which is now Akamai. I co-founded Zenedge, which was a DDoS and replication firewall company, got acquired by Oracle. Yeah, and I'm excited to share today basically how we think about red teaming DevOps.
All right, let's do it. So, with that in mind, let's start talking a little bit about DevOps. So, DevOps is a known as a combination of cultural philosophies and practices that are aiming to increase in organizations' ability to deliver applications and services in a streamlined fashion and usually in a high velocity. Next. So DevOps has become very popular because one, it helps to deploy applications in a very efficient, streamlined manner. It helps share responsibility between teams and enhances collaboration if done well, of course. And if done well, notice that I'm throwing a lot of ifs here, and you'll see why soon. You could also use DevOps to apply security software development practices as well as platform. That usually is a challenge and is an opportunity for our teams. What another good feature of DevOps is you can scale and manage infrastructure. So there's usually the DevOps comes from development operations. There's a balance there, and there's a balance in a challenge as well, which we will address in a minute. When we are talking about DevOps, we're talking about make, build, test, and deploy applications along with infrastructure. And the DevOps practices have become a key factor in the expansion of cloud platforms. I want to clarify that we're going to focus on DevOps basically linked to a cloud environment. DevOps is not something recent, but we're gonna focus it from the perspective of a cloud-related infrastructure processes with DevOps. So something that we're going to focus in this presentation is what's called the DevOps toolchains. And the DevOps toolchains is known as a combination of tools that aid the delivery and development and management of software. Basically, they are conceptual separations of the DevOps process. And once we move on into the breakdown of the tool chains, you will realize that there is a quite a bit of tools that you are probably heard of or see in your enterprise in your environment, and you will understand the reason why we have decided to break down these two chains because it's easier to approach it from the perspective of pinpointing attack vectors and pinpointing weaknesses at the enterprise security posture level. So go ahead. So here's a classic example. This is a very popular graph. I found this on the internet, but it's very descriptive of what DevOps tool chains are. So DevOps tool chains are basically divided in a number conceptually in a number of phases, right? So we have things that code, build, test, release, deploy, operate, plan, and monitor. So usually, as you can see there, this DevOps tool chains have a number of tools that are primarily used during these phases. And you can see very familiar and popular tools here, such as, for example, for coding, you have things such as a container operating framework, such as Docker. You have GitLab, you have GitHub, you use things for building packages such as Jenkins or Circle CI, or testing applications via Selenium, or releasing them via Terraform, Ansible. And of course, as you can see in the graph, there is lots of Kubernetes. Kubernetes is a fundamental framework that you will see traversing practically the entire tool chain of phases. So this is something that you have to pay a lot of attention, and that we will not be focusing strictly on Kubernetes in this presentation, but it's something that I highly suggest you start getting familiar with, because it's pervasive and it's almost in every single phase. And then finally, you have things such as uh, applications that are used for planning, such as GitHub or Jira. So if you use Jira, a lot of people are familiar with Jira, and usually when you talk about Jira, the word agile will come to mind. And agile, if you ever work for a software development company, it's a sort of a philosophy with procedures and ways of integrating teams and achieving goals, and eventually releasing features or updates to software development. And finally, we have Monitor, which is usually we'll see here is it's tools that are used to develop and have visibility into some portions, because some of these technologies are quite a bit new and evolving, and in all honesty, it's a challenge to have visibility in some of them. So let's move on. So pretty quick here. This is um, a graph that basically shows the flow of what we call the DevOps CICD pipeline, which is continuous integration, continuous delivery, and it basically goes from plan, code, test, build, release, monitor, response, learn, and so on. One of the things that you would realize during DevOps and CI/CD pipelines is a lot of these components are ephemeral. Ephemeral means they're used, deployed, and then discarded depending on objectives from the developers or the organization itself. Also, other stuff that you should be aware of is one of the advantages of this process is that you can create what is called elastic architects, architectural deployments, and that means that you can enlarge or shrink the amount of resources that you're using depending on the demand or the needs of whatever application or service that you're trying to serve. Let's move on. So here is a very granular breakdown of what we consider and call the DevOps attack surface. And usually involves the CI/CD pipeline, and we can see how now by guiding ourselves with the conceptual tool chains in the different phases, we can take a look at a specific products that are involved and related to these phases. So we had things such as, for example, the code phase. We would look at things such as source code repository. So we look at things such as GitHub, GitLab, SVN, or even S3 buckets. Things for building products for building. We have Travis, CI, Jenkins, Circle CI. I was actually part of an organization where we were using Jenkins, and our Jenkins platform was actually vulnerable to a remote code execution. I actually was able to test that, and was able to witness the challenge when you use these platforms in production, and you basically can take them out or can't even patch them. So when you are doing an engagement from the red teaming perspective, these things can be very, very helpful. And a lot of times there is not much visibility or monitoring into them. So continuing on this on the same slide, we also need to look at things such as the container operating framework, such as Docker or Vagrant, things such as the planning tickets, things like Jira or Trello or GitHub. The IaaS provider, which is usually involved into releasing, deploying, and operating. And then here we had to take a look at the Kubernetes, right? You had to take a look at Kubernetes because Kubernetes is the open source framework that is mostly used for deploying containers. Containers are prepackaged software and stripped down like virtual machines that are basically designed to run specific services or applications. Also, in the part of release and deploy, you also had to consider things such as languages such as PowerShell DSC. I've seen some work in the community abusing PowerShell DSC and things such as Ansible or Terraform or CloudFormation. So the languages themselves can be used for enhancing exploitation and post-exploitation lateral movement. And this type of languages, as we will see soon, they all have had either CVEs or exploitation related information already public. So finally, we have things such as monitoring tools, like again the classic ones such as ELK or Splunk, and testing tools such as Selenium. So let's go on the next one. So this is sort of a slide that, since everything is visible now because of the pandemic, so are the files. So with this in mind, let's get on to how we'll red team this thing. So when we talked about red teaming, we're basically talking about engagements that are cross-domain functional, meaning we target an organization with an adversarial mindset, and with this adversarial mindset, it's not restricted or as limited to a specific scope. So red teaming engagements usually go beyond a pen test, which might be reduced to a specific site of IPs, for example, a specific application. In this case, we're targeting an organization with a mindset of an adversary, and we are trying to replicate such TTPs and see how resilient the organization is should we be successful in attacking this organization. So we create hypotheses and methods and attack tools that would allow us to basically test and prove the security posture and resilience of the target organization. So in this case, because we're talking about DevOps, obviously, and this is the reason why I brought you from what DevOps is, what are the things that are involved in DevOps, we had to probe things such as, is there even an awareness of a CICD attack surface? Is this an organization that has pipelines where they had no visibility monitoring, or like we're seeing in the field, developers are getting global admin keys. If you give a developer a global admin key, for example, in AWS or any other provider, and these keys are found in the wild, or this developer is phished, now you're in deep trouble, because basically as a global admin, attacker can do whatever they want. They can abuse the infrastructure. They can pivot. They can create artifacts to do further phishing, and most importantly, depending on your infrastructure, they can even get a hold of data in private IP that has not been staged yet or tested, and is bound to go in production. So this is very important. Also, you need to understand that we are moving into a hybrid sort of corporate world, where we have a lot of the infrastructures moving to the cloud. And by moving to the cloud, we're starting to see what we call a hybrid environments where there's a gradient. And this gradient is where the perimeter and the cloud infrastructure components are meeting. And this makes now the north-south the new east-west. And we're going to show you that in a minute. So other things that you should consider is, can you go back for a second? So other things that you should consider is, before we get onto how we're gonna address this as red teamers, is there a mechanisms to assess the risk or deploy controls in this type of attack surface that we are proposing? Is there monitoring tools? And again, like we said before, ultimately test resilience against this type of attacks. So sorry, let's go ahead and move on. With that in mind, let's take a look at how we will approach this, right? So basically, the operator, the red teamer, will use the internet, or which will be basically most of the assessment, and the clock and dagger. The clock and dagger means you're going to have to set up your red team infrastructure, usually domain fronting, obfuscation of C2s, third-party C2s. We'll see that in a minute. And then you're going to have to embrace the target. And by embracing this target, we divided this into two main components or domains. One inside the perimeter by looking at API keys, certificates, keys or certificates that can be within servers or within desktops, mostly developers or administrators, testing tool sets that can be attacked, platforms that can be attacked. Like I said before, I was part of an organization where I was able to basically pretty much compromise an internal Jenkins server that was vulnerable by an RCE exploit. Of course, as we talked before, we talked about languages such as Ansible and PowerShell DSC. There is, again, some initial work on using PowerShell DSC. PowerShell is an example of a scripting administrator, developer, like friendly language that has basically been weaponized and repurposed for lateral movement and post exploitation. There are entire frameworks. Some of them are signatures of red teaming, such as Empire, which are based on PowerShell, right? So this is something that, in my opinion, will evolve, and it will consist in targeting this languages, what at times is called IAC, infrastructure as code. So here we have other elements such as, obviously, common phishing of admin development creds for cloud and platform tools, and then obviously exploit the actual SDK or CLI as a client, like CloudFormation, right? So from the other side, then we can try to find which will be outside the perimeter. We will look at web services, we look at APIs, we look at storage objects. And when I talk about storage objects, it can be volumes that have read or write permissions, and usually, unfortunately, things such as S3 buckets are openly showing themselves on the internet. There are tools that you can use to actually search for those things. Today, we're going to show you a tool that actually finds keys that are leaked on repositories. Continuing with this, you will look at API keys, vulnerabilities themselves. So because, and this is one of the objectives of this presentation, is to show you how the DevOps basically enlarges the attack surface. So you're not only you have to basically pay attention now at things such as where you are prepackaging these applications, say containers, right? So like I said before, there is this developer and operations, and there is this concept called no ops. So no ops is, in some development circles, the belief that because now I don't have to order a server from IT, I don't need to be much aware of the hardware and operating system that is the base of where I'm putting my code. That by itself it's replaced because containers are technically abstraction layers of hardware and software. And what happens is at times, because there's not much attention paid to it, then the operations part, and that includes most of the information security people and SecOps, for example, may create a gap where developers are basically downloading all kinds of stuff from the internet, including going into public repositories of containers, downloading them. They don't even scan them. You don't know if they're a backdoor, if there is stuff in there. And we're going to show you an example today. And then you push that into your internal cloud, into your container registry, and then trouble ensues because it's a lack of knowledge and lack of visibility at times. So moving on to finally one point before we move on, when there's almost an entire industry around misconfiguration of cloud platforms, right? It's what you hear about CSPM, Cloud Security Posture Management. It's basically based on misconfiguration. So what happens, the reason why this happens is because organizations are embracing the cloud and somehow they think that they're not responsible. Somehow they think that the cloud is something that will not affect them because they're physically not running it, and that's a huge mistake. As much as we would like that to be the case, it's not. A lot of production code, databases, security artifacts are being placed in the cloud infrastructure. So by you not protecting or neglecting or not even having any visibility in your cloud environments, you're in fact exposing your perimeter, and that's one of the objectives that we want to prove today. Let's move on. So here's some thoughts about red teaming DevOps from the attacker perspective, like which again we want to emulate, have the adversarial mindset, and use tools or basically operationalize TTPs that would allow us to probe the resilience of the target. So things such as third-party SaaS or PaaS or IaaS, using C2s such as Twitter or GitHub or Gmail or Box. Most of the times, this PaaS are part of most organizations. How many of you are using Google Apps or Office 365? If you're able to serve or even call back from those platforms, it's very, very hard that you will be caught. And that includes the platform where the target is running. So if you're putting C2s in AWS and your developers, the target developers are operating under AWS, it's unless you have a very strict and granular monitoring, this is you're not gonna be able to detect this. It's very hard, and you had to have a very wide and visibility that includes both perimeter and cloud. Um, Obviously, you had to research third parties. And when I mean third parties, I mean contractors, I mean providers, analytic providers at times that have either shared keys or access to mounted volumes with information or data that can be sensitive and that can be used for further extension or compromise. Also, like we said before, again, and this is very popular, and it's right now one of the main drivers is the misconfigurations. Misconfigurations. So I have seen entire organizations where they have X number of developers, and every single one of them has an admin key. So these guys are downloading and pushing everything. So every single one of them is potentially an administrator that you can phish and that you can compromise. If we add to this that we have organizations that have hybrid infrastructures, where some of the stuff that they're deploying has actual visibility or ways into the perimeter, this is golden for a red team. So also consider that many of the development is done on open source. And when you do development open source, there's usually lots of forums and lots of collaboration, internet collaboration, public collaboration places where you can find hints and you can even read code and patches that these organizations may indeed be applying, and that may lead you to discover or further get knowledge into the possible inner workings of their development and operations department. And many organizations, again, and I just mentioned this, do not have any control or repo version control or uploading rights or even sharing. So it's a good for all. I can right now probably go to Docker Hub, download something, and unload it myself. That stuff may have a backdoor in it, crypto mining, something that is watching my internal networks. Because as you may know, there are what I call the cloud ones and the cloud lands, which is environments that are isolated, but from the logical perspective, they are not exposed to the internet. However, if you're able to get vision into it because of the architecture because of the architectural functions and certain components, for example, Kubernetes, where the nodes are constantly communicating and sending information. If you have visibility in some of those environments, that is quite an advantage. So let's go ahead and move on. um, emphasizing on this, target release deploy languages: PowerShell, DSC, Ansible, Terraform. Dependence on the clouds means many times there is no communication. This is also very common. There's no communication between the cloud provider and the actual security support. Like I said before, if the development team is actually doing whatever they want and they're not paying attention to security or operational security, sometimes you find out because of the bill, not because there's an alert or because you're even watching it. So this disconnect between these two worlds, again, the DevOps, the operation, is, in my opinion, a huge problem, and that has to be fixed. And I'm seeing it. I'm actually seeing it in the field as I'm getting colleagues and customers asking me what to do about this, because basically they feel that the certain departments are bringing everything from the internet. They're not cleaning it. Then there's no version control. There's no asset management, so you have no idea what is in there. At times, they may even leave containers for applications that are vulnerable. Nobody has touched it. You might be able to compromise it or find it and find your way in. I've seen this and done it in previous engagements. If you achieve access, obviously you can emulate target behavior. Many cloud environments have very poor vision. This is, again, visibility, and it's very hard to catch cross-account activity. Cross-account activity is seen differently in the different vendors. So, for example, Amazon uses Assume Role. We're not gonna here get much into detection, but I can tell you that unless the person who's managing this infrastructure has a good knowledge of RBAC, a specific RBAC in the cloud platform that we're targeting, in the organization that we're targeting, most likely they won't even see it. And then cloud-facing applications in many environments have partial or direct connection to internal environments. I said this before, and this is the future. And we even have products where there is a VPN sort of a product that basically you can connect directly from your perimeter. If you can get access to that is absolute gold. And like I said before, pivoting north-south is possible now as lateral movement, because if we're able to compromise cloud applications and we find containers, servers, applications that are pulling data from inside the perimeter, then we can do north, south, east, west. As simple as that. Let's move on. So here's a sort of examples for you. So you can, we will be sharing this, this will be recorded and we'll be sharing as well these slides. This is a breakdown of the different tool chains. And as you can see, we divided it by the products and we divided it by, in some places I put MITRE techniques, in some places I put the CVEs, basically to exemplify and show you visually that just with the DevOps, with the CI/CD pipeline, look at all the opportunities that are presented to you as a red teamer. So let's move on. Every single tool chain, every single product has had some sort of an exploitation, some sort of a vulnerability. Use it, add it to your to your to your handbook. It's again this for from the red teaming perspective. The whole DevOps CI/CD pipelines, it brings an extension and a brand new opportunities of probing and compromising targets, basically organizations. All right. So with this, I think we're gonna go into the practical demos. So Jose, take it away.
Yeah, so again, just quick recap. Rod just gave us a really good rundown on, as red teamers, why should we care about DevOps, what the attack surface looks like. I wanted to show some practical examples. I'm going to just deep dive on like some just real world examples you can just take away from this talk and use, right? And the first thing I'm going to pick on is essentially exploiting GitHub for secrets. And this is somewhat a commonly known thing you can do, but mainly from a blue team perspective for defense, it's still a very viable way to just find secrets out there. And why is this a really valuable tool to have in your toolchain is it's a low-hanging fruit for an attacker. It's very easy to execute this attack without, or find secrets essentially in GitHub without really alerting your target. As developers develop code, it's very easy to commit mistakes. Usually, again, if a developer is writing code specifically in a DevOps workshop, they usually have a high privileges accounts because they can make changes to some sort of production. Ideally, right, you'll run into one account that have changes to production or CI pipelines that have usually deploy rights and that kind of stuff. Also, it's very hard from a developer perspective, even once you find a leak, to clean it up. Like going back and rewriting or deleting things from Git history, it's actually pretty painful if you've ever tried it, and requires rebasing of your code and so on and so forth. The other reason, again, I'm showing this example is Git is pretty much an industry standard. GitHub, it's pretty much an industry standard. But there's also many targets besides GitHub, right? You got GitLabs and Bitbucket out there. So it's not only a very commonly used tool, but this kind of a workflow can apply to other targets like GitLabs and Bitbucket, which also run like cloud code repositories. So I first wanted to show you what I call exposition number one. And this is a tool called shget, which is, actually, let's just jump right into it here before I start explaining it. Give me 1 second. Let me share with you a video. And Rod, can you confirm that you can actually see the video screen?
I can see it. Yeah. There you go.
Perfect. Awesome. All right. So shget basically is a tool that allows you to view secrets from GitHub real time. And what I mean by that is it literally will hunt for GitHub as people are committing code in for things that match potential secret leaks, right? And so, for example, here you see it running. It checks for about 120 things that it considers, again, potential secrets. And immediately here, when you run it, you'll start seeing events flowing in for things like a shell configuration file committed or a log file committed that could potentially contain secrets, right? If we take one of these shell configuration file, again, for example, and we literally grab so this looks like as a C shell, just based on the URL, it's a C shell.rc, and we grab that URL and we pop it into a browser. We can actually see, again, what the user committed because it's public facing. And indeed, there's a Z shell.rc D folder. And if we open the actual file, this looks to be a false positive in the sense that, yeah, he committed the file, but there's no actual secrets on this bash in here, right? Sometimes like it's practical to include like tokens and stuff like that in your RC file. Again, I have a ton of fun just watching real time the data that comes through here. If we run it, you'll see things again like AWS potential like S3 objects committed. In this case, for example, a Django secret that got committed. And again, we can open the URL and verify if there's an actual secret in there or not. That's one of the things that the tool really doesn't do for you. It kind of has a search, a real-time search on everything that's coming through on what may match what's committed, but it doesn't actually go into the content of what's committed and verify that what it actually found is a secret or not. In this specific case, the Django secret, when you leak it, you can actually use it as an attacker to get RC on the platform, on the web app hosting platform. So again, this tool highlights how prolific the mistake of committing secrets is in GitHub. If we dig into the actual tool, the way the tool works, here, I'm just gonna wait into the actual execution finishes. But if we dig into the actual how the tool works, like you said, we loaded earlier, there's 120 signatures, and there's a config file that explains or basically contains those signatures. And when they call signatures is basically a search, a GitHub search, specifically what GitHub calls an advanced search. So things like, pass it an extension of P12. This is a potentially cryptographic key. And again, if somebody commits a file with P12 in it, it doesn't mean that it has an RCA the private key in there. It's just there's a potential key. So this is where, to a certain extent, get falls short. But I'm just showing you this tool so you can see how, again, prolific the problem of committing secrets is. Highly recommend you, if you can, after this talk, clone it down. All you need is a GitHub token to run it. Clone it down and run it locally, so you can see how fun and the amount of data that just people leak in there. So that's Shget. Let me go back to the slides. Bear with me. So that's exposition number one. Now, there's some challenges, again, with hunting for secrets in public repository. And the first one that I ran into at least is APIs from some of these providers actually limit you. And what do I mean by that? For example, Get is able to do those searches real time and not pass a specific username or repo because it's only looking at real-time events coming out of GitHub. It's not doing a historical search. GitHub actually limits you if you're doing a historical search, unless you're passing very specific parameters, it limits your query by a user or a repository to actually then check content for it, which is why, again, Get cannot verify whether the actual content is a secret or not. Also, again, scaling verification is painful, is a challenge. It's not very practical to go into every URL that you're getting from SureGet and copy it into a browser and check if that's actually a secret or not. Right? So doing this by hand really doesn't scale, which it makes it right for automation. There's no current automation for the entire workflow of like parsing that secret, storing it somewhere, and reporting it, right? So what we did is we built this tool, actually, as a result to solve this, which is Git Wall Hunt. And let me show you a demo of that really quickly. Go. Can you confirm you can see the video?
I'm looking at the GitHub page. Yes, that's the video. Yeah, there you go.
Yep, perfect. All right, so Git Wall Hunt, again, it's a tool we open source. The URL is at the end of the talk. It's pretty easy to get started with it. Very similar to Get, which you just install it, you configure your token into it, then you run you'll run hunting searches, and I have some sample searches in there. And ultimately, the results of those verified credentials from the searches get stored in a JSON log called results.json. Some of the, again, I mentioned I have some sample hunting searches just so you get a good idea. There's I put searches in there that potentially find GCP JWT tokens or GCP secrets, which give you full access to, or potentially full access to somebody's GCP account. Same thing with AWS secrets. Same thing with Azure tokens or JWT tokens. GS utils config login. So for like Google Drive and similar like Google services, you can abuse them as well. Kubernetes configs. So very commonly leaked things in GitHub are full-blown kube configs, which have usually also secrets in it. Jenkins credential files, Circle CI credential files. So we're not leaving out the CI pipelines in here. But again, with the value of the tool is not the fact that you can actually run that search historically, but also it will validate for you whether there's actually a secret inside the content that was committed or not. And it does this by basically running regexes on that content. And there's a bunch of regexes here. I listed like the ones that we're checking for different kind of tokens. I graciously borrowed that from Trufflehog, so I actually didn't write the regexes myself, so thankfully. But yeah, it would have taken quite a bit. But it's very easily extendable, right? It's just adding another regex for checking another potential secret. So here, let's try to find AWS leak secrets really quickly. Again, just to show an example of how you would use the tool. So you first run the search, and again, you copy and paste a search on the CLI for AWS, and this specific search is looking for anything that was committed under .aws path, and it has the file name credential. Very basic, simple search. Again, I borrowed this one from Shke. It's one of the searches they have, but they don't actually check for the data in it, which is what we're gonna do. And when you run it, you immediately see that there's 247 potential leaks right now. Right? Like I run this, I think the 13th, a few days ago. And so again, the tool is going to verify out of those 247 potential leaks, which ones actually have secrets in them. So it actually goes through each of the repositories and then runs regexes on all that content. The regexes that actually come back and match, it stores it. So you see there's one of the regexes that matched, it's for an AWS API key. So if we actually go to the URL, you can see, yeah, the API key for this person was leaked, or it's out there, right? You can essentially use this and abuse the heck out of their AWS, right? Or leverage this key now to further move into their environment. And so, yeah, again, tool runs, goes through every result. It not only processes individual secrets, but it can capture multiple at once. So again, because it's running all those regex checks, it's one of the files with more than one secret, it stores them. In this case, I think this gentleman here, or this developer, leaked about four different users. I'm assuming it's a gentleman, sorry. But yeah, and so at the end of the execution, you can review the results into results.json, in results.json. And again, results.json, the main reason, the main idea for us, or for me to put this output here was I wanted to index this in Splunk so I can store it and report on it historically, like who's leaking secrets, when, etc. But that's a later conversation. For now, again, also serves as a audit of what we found, right? And you can see the secret, what matched gets stored, a timestamp, and the actual check, plus the actual URL. If you, again, from this execution, we saw 247 results. If we just pipe this to JQ length, we can see that out of it, 178 actually were verified credentials just from that search. So again, let's try the same thing with Kubernetes secrets, just to see, just another example, right? Again, this search is looking for anything that was committed on the kube with file name config in it. And it's going to, again, verify if there's any credentials inside that file. This one actually had 173 results back. And you immediately see there's a few that already have some confirmed leaks. In this case, let's verify this one. This one seems to be for Google OAuth access token, or JWT token. And you see that the config has actually CAs in there. Again, from a red teamer, that's not necessarily too interesting. I don't know if I can authenticate with this. If they're put the public CA certificates, I don't think this were private keys for them anyways. But again, down there, very interesting data is that the access token got leaked for their GCP, for G Cloud, and it looks like it was something under Jenkins pipeline that they were using. Now I can use this token to come back and have the same access right as a Jenkins pipeline on their environment, which is extremely dangerous. Let's let it finish the execution. We can review the results again. And again, you have all the result sets there historically if to do analytics or whatever else you want on it, report on it, so on, so forth. So that's Git Wild Hunt. But you know, again, I showed you an example of finding secrets just through GitHub. And I picked up GitHub. You can apply the same methodology to GitLabs, but there's always good old fishing for finding credentials. And actually, Rachel, a fellow Hack Miami member, just posted this week a really cool blog on how to use a tool called Zfisher plus the Azure the Azure service to host a phishing page for Azure. That again, you end up with an Azure URL out of it, which is pretty cool. It looks really realistic. So there again, when you're going into this engagement, just think of multiple ways how can I achieve hunting for secrets. If you can use GitHub in a passive enumeration manner, like we are, to find something valuable against that target, phishing is still a good, valid choice. Why not, right? But I guess the next question is, okay, so now I got credentials, whether it was phishing or I found them and leaked. Now what do we do with them, right? From a red team perspective, and I just thought it was a joke. I was gonna say, have you heard of the MITRE ATT&CK matrix for cloud? Yeah, so there is actually a technique, and we're just kind of speaking on this one again, just for sake of example, of like implanting container images. And one of the things I want to point out is MITRE ATT&CK matrix mitigations for this is basically to audit the integrity of your image and to do code signing and verify trusted sources. I'm going to be honest with you. I think in the 3 last shops that I've been in that use containers, we didn't do it. We didn't do code signing or checking for code signing on our containers, and we didn't audit them either. So I don't know how I don't know how common that is across shops. And again, I'm just using my own experience to measure it. But and a general attack flow for implementation, and what I'm about to show you. Because there's a lot of moving pieces here, I wanted to just give you a high-level diagram of what it looks like. We're first going to assume that we use Git Wild Hunt to find some AWS credentials for our target. We then grab those credentials, and we're going to use those credentials to authenticate to AWS's Elastic Container Repository. And once we authenticate, we're going to do a few things. First we log in. Then we are going to enumerate what repos are part of this repository for these keys, if they have any, what images the repos have, right, in them, and then we're going to pull an image and implant it. And so when I pull the image, we're literally going to bring it down. We're going to modify that image, or the container image, and implant it with a Merlin agent by modifying the Docker file. If you've never heard of Merlin, actually, Joshua Schultz, which is another talker who's going to be talking later today, actually turned me into it. But it's a very cool C2. And I love it for 2 reasons. One, it's built in Go, which means the agents are pre-compiled. There's no worrying about dependency and installing interpreters and any of that. You literally have a binary that you run. Second, the callback mechanism is HTTPS. So it can blend very well with any traffic. And so we're going to be using Merlin as an implant, and we're going to push this modified image, or this implanted image, back into the ECR, the container store. And after this is in the container store, then Elastic Container Services, which is the actual services that run containers, think of like a hosted Kubernetes by AWS, will take that updated container and run it as a new instantiation of it, right? And so at that point, the implant will not only execute, but it'll also, like, the implant will execute plus whatever other service is going to run in there. So it's sitting, and the implant is going to call back to RC2. RC2 is also going to be hosted. So RC2 being Merlin as well, right? It's going to be hosted in AWS. So all the Defender or all the blue team or whoever see is an HTTPS call back to another AWS instance. Completely, again, unless you're looking for, unless you're interested in HTTPS inside AWS, which is extremely rare. I've never heard of that. Very stealthy, for lack of a better word. Again, this process is going to get kicked off by 2 actions, either by the creation of a new instance, manually, where somebody goes into SES and creates a new instance, or if this person who leaked the token has a CI pipeline for deployment and automatically deploys new image pushes, it will automatically then be, the C2 will automatically be instantiated with a new container that comes up. So let's look at what implementation looks like really quickly here. Let me, again, I'm gonna pop another video up. Rod, just confirm for me that you can see the AWS screen.
Yep, correct.
Yep, perfect. All right, so first, again, I just want to walk really quickly through what the regular environment looks like. So again, we have ECS, Elastic Container Services, and this is running a default compute unit, and we have multiple tasking here. So one task is specifically Nginx, and again, I'm kind of showing you the developer's DevOps view, right? And this Nginx service essentially is, again, it's hosting a website, very simple website, nothing fancy. And if we look into how this Nginx service gets built in the task definition, it essentially comes from a Elastic Container Repository image, right? So there's a container behind this the service of this task. And if we expand the image here, we see that it's somewhere hosted in US West under Nginx latest, right? So this is, again, this is the environment we're going to be essentially abusing. If we go to ECR, again, we can confirm there's a repo called Nginx, and there's that repo URL. So for setting up our attack, again, we're going to have two terminals here. We're going to have a C2 terminal, which is going to be running our server, and then we're going to have just like a workspace terminal. I'm renaming them, again, just for the sake of like explanation here, but Merlin C2, again, very simple to run. It's just a binary you download and you execute. In this case, I'm going to listen on our interfaces. You literally, again, you just literally run it. You don't need to compile any dependencies or anything like that. And immediately comes up. You see it's listening already on 443. This is running on Ubuntu 18.04 on an AWS instance, like I mentioned earlier. So we're hosting our C2 on the same environment, essentially the same cloud provider for obfuscation, further obfuscation. So again, the first step for this attack is we assume we have a leak credential that we're going to use, and we're going to use to authenticate to ECR first with that credential. So, and in this case, we're using the AWS CLI for authentication purposes. We're going to be using the CLI mainly for the attack. So first thing we do is we grab the password. We grab a token, authentication token, essentially for ECR, and we pass that token over to Docker, right? And in this case, the reason Docker needs this is Docker is we're gonna use the Docker CLI to operate on this repository in a second, right? So we pass it the authentication token plus the URL where the repo is, and then next step is we enumerate what repositories are available under this key essentially. Okay, so we run the describe repository. We see there's essentially three of them: toss a coin, test, and Nginx. And the one that we care about here is Nginx, so that's the one that we're gonna go ahead and pull down from. But first, let's see what images are available on this Nginx repository. And to do that, we enumerate the images. So again, running the CLI, we just enum list images, pass the repo name, and you'll see that here there's really there's a few images, but one has a tag, and again, it's very common to push the latest tag to production in a regular CI pipeline, but I'm assuming here that whatever they're using as latest, this developer, is what they're getting out, and so that's the one that I'm going to go ahead and implant. So next step is, again, because we authenticated with Docker, we're going to go ahead and pull down the image for Nginx, and then what we're going to do is we're going to modify that image with an implant. So if you look at the Docker file, the standard Docker file for Nginx, it's pretty straightforward for this image. It's just, again, from Nginx, it runs an apt-get update, it copies some static site, and then it runs the actual Nginx with daemon turned off. So it means it runs it in the foreground. We're going to, again, do our implant in here. First, I'm going to grab the implantation agent from Merlin. Like I mentioned earlier, they're off compiled, they're on the releases, which is nice for every platform, so Windows, Linux, and Mac. We're going to be doing this on containers, so I'm going to grab the Linux agents. And so we copy our agent down to the same build repository for the Docker file for Nginx that has a Docker file for Nginx. And then we modify that Docker file to include and run our implant. So copy our implant into the actual container and execute it. So modify, yeah. I had already built this on the demo, the Docker file in another directory, but I'll still show you what it looks like. Basically, again, same code. We just copy the static directory. We're still doing the update, but now we're moving or copying over the Merlin agent to something called opt health check, just for, again, for obfuscation, not to make it look too obvious. And then in this case, we're passing it the URL for a C2 and then still running Nginx. Now, I just want to make a quick note. You wouldn't typically pass the URL like that. Like you probably want to pass a domain for that's behind redirectors. So in a real engagement, you will probably be hiding that C2 IP through redirectors. RefShell is another really great tool and blog on how to do that. So yeah, next thing is we recompiled or we repackaged this Nginx image with our changes, and we can see that again now our changes are our implementations are in there. The command to execute health check with a URL, and then we tag it so it gets properly matched with the latest tag when we push it over to the repository, and then we push it. In this, yeah, and so we just got to verify when we push it that again you're pushing it to the right URL, which we found through the enumeration earlier. So because I don't think this Nginx image is too large, it should go pretty fast. But again, we got a new hash SHA digest, and because again you can verify here the fact that the actual image now has been updated with the latest SHA, and you can see again that just the pushed time matches the time in my machine as about a few seconds ago. So we did get the new image in there, and because in this demo I didn't build like a CI pipeline. Imagine if DevOps had a CI pipeline, latest would essentially be deployed automatically. But in this case, I'm going to kick it off manually. And when we kick it off, I mean like I'm going to create another running instance of the Nginx task in ECS, so it actually runs the implantation code. So that's what you're seeing me do here. So you see the new task essentially provisioning now. And we go back to our C2 and wait for a session, right, from the callback. So it takes a few seconds for something like a task to come up in AWS. So, but after that, whenever AWS runs that container, you should see an implant show up, and we do. You see there a new authenticated agent, and it assigns a UUID for that agent name. And now we have full, essentially, access to that container that just got deployed in an AWS hosted service, essentially. So if you go to interact, you can see Merlin has a bunch of capabilities, things like being able to run shellcode or download something right into the machine, or just full shell control, right? So full shell access. Obviously, you can kill and destroy the agent if you're done with it, if you want to. Yeah, so basically full control of the machine. Right? If you run info, you can see, again, this is running obviously Linux because it's a container on the site hosted, but you can see that the host name is actually coming from something internal in AWS. Like I said, we're using ECS, so that's hosted. We even the user doesn't have any control of this, right? The less control you will have from Kubernetes. If we list directories, you can see that this is obviously a Docker container is a Docker Infinite, and it just recently got created. So that's an implementation in a nutshell. Now, I wouldn't stop at implementation. Implementation is just, again, the tip of the iceberg of ways you can abuse using a token, but there's a bunch of other ways to go about this. There's a great project by Jason Grace and Sandia Labs called Master of Servers that allows you to leverage the same concept, but allows you to leverage Ansible, Chef, and Puppet as post-exploitation tools. Like Rod mentioned earlier, it basically weaponizes this configuration management systems to build persistence in an environment. Basically like getting God mode in somebody's environment, for lack of a better word. Not to pick on Splunk, but like there's easy ways to backdoor Splunk, like just uploading an app with the callback, right? Maybe you can find a key that has all these privileges to update containers, but you do find from there you can pivot to a Splunk instance that's running. Well, backdoor with an app, boom, now you have persistence, right? Rod, I don't know if you want to comment on further ways
Sure.
of enumerating here.
Yeah. Well, basically, once you get a hold of or in the cloud infrastructure, you obviously you want to enumerate further cloud resources, Kubernetes clusters, private buckets, further repositories, segments of cloud networks, probably code that is being tested, sensitive information that's being pre-staged or is going to make it to production. There's a tons of possibilities once you're able to get access within this cloud environment. And like I said before, most of the enterprises are moving to architectures where they use a hybrid approach, where many of these applications actually have visibility or communication with the perimeter, inside the perimeter. And that's why, like I said before, north-south may be the new east-west, because we can start at the cloud and we can end up moving around workstations or servers, because they're connected either by the CLIs, the SDKs, or even the VPN type products, which basically make connection to the cloud seamless. And I think that's actually one of the things that the vendors are trying to do and pushing for in the future. So that will make even easier to adopt cloud architectures, basically. I hope today you were able to get some good information of this ongoing and new opportunities for red teamers and penetration testers and adversaries in general, because they're there. And there's unfortunately right now we're going through one of those phases in the industry where it would take unfortunately a lot of compromises and a lot of bad stuff to happen for organizations and enterprises to change their security posture.
And again, here's the list of tools that we use today. I will be sharing the slides afterwards as well. But again, get to see real-time leaked secrets in GitHub. Get Wild Hunt for actually searching for secrets and validating them automatically. Merlin was a C2 we ended up using. Highly recommend you check out Zfisher and RefShell's blog on how to use it for Azure, and Mose for post-exploitation. That's what we want to share with you today. We're going to be in Discord. If everybody's going to jump in there, that's where we'll be answering questions. Otherwise, feel free to message me or Rod on Twitter. Please, we're super, we love feedback. We love questions. So I hope everybody has a great day.
Thank you very much.
Thank you so much, guys. Thank you, Jose, and thank you, Rod.